right, welcome back. This is Miss Best, and this is completing the square part 2. I'm just going to go ahead and get into the first example. The example is 3x squared plus 24x equals 129. All right, so the difference between this problem and the last problem is that we now have a leading coefficient other than 1. Okay, our coefficient is 3. Okay. And our C has already been moved to the other side. This 129 has already been moved, so that kind of cuts out a step for us. All right, so now because we have a leading coefficient, the first step has changed. We're actually going to divide by the leading coefficient first. So I'm going to rewrite my problem. 3x squared plus 24x equals 129. And we're going to divide by A. All right, so divide everything by 3. 3 goes into 3x squared, x squared times. 3 goes into 24x, 8x times. And 3 goes into 129, 43 times. All right, so now we have divided and we can move on to completing the square. All right, now our A, B, and C have changed. Our A is equal to 1, our B is 8, and our C is 43. All right, so I'm going to plug my B into the formula, B over 2 squared. Our B is 8, so that becomes 8 over 2 squared, which will become 4 squared, which is 16. So 16 will complete the square. So I'm going to write my next step, which would be x squared plus 8x plus 16 equals 43 plus 16. Remember, whatever you do to one side, you have to do to the other to keep it balanced. All right, so now I can factor. Okay. And I'm going to factor this perfect square trinomial right here. So the factors of x squared plus 8x plus 16 would be x plus 4. So I can write x plus 4 squared, and then 43 plus 16 is 59. All right, so the next step is to take the square root of both sides. Okay, that's going to leave me with x plus 4 equals plus or minus the square root of 59. Now, 59 doesn't have any perfect squares that are factors, so I'm just going to keep it the square root of 59. For most problems in completing the square, they do not want you to get a decimal or something like that. They want you to just keep it the square root of that number. So my final step is to subtract 4 from both sides, and my solutions would be x equals negative 4 plus or minus the square root of 59. All right, so we have our solutions. Now, what if your question asks you something about the vertex? Well, you would need the vertex form. So whenever you need the vertex form, you can go to this step right here where you factor your perfect square trinomial. Okay, so I'm going to write that here. Okay, it would be x plus 4 squared equals 59. Now remember, in the very beginning, we divided everything by 3. We divided everything by 3. So when we talk about vertex form, we have to put the 3 back in. So we're going to have to multiply both sides by 3. Okay, so I'm just going to put 3 on the outside here. 3 times x plus 4 squared, and then 59 times 3. All right, so this can stay here. 3 times x plus 4 squared. I don't need to distribute because this is how vertex form looks. You have the a on the outside, then you have x minus h, and then plus k. So all we're doing now is we're multiplying 59 times 3, and then we're going to move it over to the left so that we can have it in vertex form. So 59 times 3 is 177. And so now I'm going to move that to the other side. So I have 3 times x plus 4 squared minus 177 equals 0. These cancel out. All right, so now our vertex would be opposite HK. Okay, which would be -4 and -177. Now, would this be a minimum or a maximum? Well, our leading coefficient was a +3. So it's going to be a minimum. All right, so the minimum value of our quadratic equation is at -4 and -177. All right, let's go on to the next example. Next, we have 2x squared plus 5x minus 8. So just like the last problem, we're going to divide by our leading coefficient first. Divide everything by 2. All right, so 2 goes into 2x squared, x squared times. 2 does not go into 5 evenly, so I'm just going to leave this 5 over 2, x, and then 2 goes into -8, -4 times. All right, so now because I have my a, b, and c all on one side, a equals 1, b equals 5 over 2, and c equals -4, I have to move c. So we're going to move c. Okay, so I'm going to add 4 to both sides. These 4's will cancel out. And I have x squared plus 5 over 2x equals 4. All right, so now it's time to complete the square. Okay, and I'm going to take b, which is 5 over 2, divide that by 2, and square it. So if you divide fractions by doing the keep, change, split, you would keep 5 over 2, change it from division to multiplication, and then change the 2 to 1 over 2, and then just multiply across. So 5 times 1 is 5, and then 2 times 2 is 4. And so now you still need to square that because our formula says b over 2 squared. So 5 over 4 squared is equal to 25 over 16. Oh, how we love fractions. All right. So now I'm going to add 25 over 16 to both sides. So I have x squared plus 5 over 2x plus 25 over 16 equals 4. Okay, fix this. Equals 4 plus 25 over 16. All right, so now I can factor and simplify. So this x squared plus 5 over 2x plus 25 over 16 becomes x plus 5 over 4 squared. And then 4 plus 25 over 16 is 41 over 16. All right, the next step is to square root both sides. Okay, so I'm going to take the square root. This gives me x plus 5 over 4. And then the square root of 41 plus or minus the square root of 41 over 16. Now, because 41 and 16 are dividing, I can take the square root of them separately. Okay, so I'm going to write x plus 5 over 4. And 41 doesn't have any perfect squares that are factors. So that just says the square root of 41, but 16 is a perfect square. So the square root of 16 is 4. And then I have to move 5 over 4 to the other side. So I'm going to subtract 5 over 4 from both sides. And I have x equals negative 5 over 4 plus or minus the square root of 41 over 4. Okay, and I can write that even simpler. Okay, I can write that x equals negative 5 plus or minus the square root of 41 all over 4. Okay, so this would be, this would represent my two solutions. It represents negative 5 plus square root of 41 over 4 and negative 5 minus the square root of 41 over 4. All right, so now let's go back and talk about the vertex as well. So vertex form, remember you stop at the step where you factor your perfect square trinomial. So that would be right here. Okay, so I have x plus 5 over 4 squared equals 41 over 16. We have to go back and multiply both sides by the leading coefficient because we divided that out at first. So for vertex form, you have to put it back in. So I'm going to multiply both sides by 2. I have x plus 5 over 4 squared equals 41 over 16 times 2. All right, so I'm going to leave the 2 in the front here. So I have 2 times x plus 5 over 4 squared equals 41 times 2 is 82 over 16. All right, and then I'm just going to subtract 82 over 16. Let's simplify that. 82 over 16 would be 41. Sorry, would be 41 over 8. Okay, so I'm going to subtract that from both sides. And so now I have 2 times x plus 5 over 4 squared minus 41 over 8 equals 0. All right, so our vertex is at negative 5 over 4 and negative 41 over 8. Okay. And is it a max or a min? Well, our 2 is a positive 2. Okay, so our leading coefficient is positive, so it's going to be a minimum. All right, so if you need to pause or rewind the video, please do so. And if you have any questions, you can post them on Edmodo beneath this video, or you can bring them to class with you. All right, see you guys later. Bye.